What's up? This is Matt Brown. I hope you're having a good day. Today we are going to take yet another look at a tool on my desk that I use every day in my job, reverse engineering hardware and doing security audits on embedded systems. So today we're going to take a look at my multimeter. Let's go to the desk. So here we are. I've got my Fluke 15B Plus multimeter. So for what I use in my day-to-day analysis of embedded systems, I will use a multimeter for two primary objectives. The first is the use of continuity mode. And so you can usually find that on any multimeter with the ohms symbol, the symbol for resistance up there. And so there's actually a mode and there'll usually be a selector that'll let you switch it into an audible sound mode when you have connected or when you have a low resistance path between your two probes. And so I will often put it in that mode, and then just to sanity check myself when I'm starting out, I will touch them together. And then let's say I wanted to find on this Raspberry Pi Pico that I've been playing around with on my desk here, if I want to find ground. So on this device, it's kind of hard to see. So a common place to look for ground is often going to be a shielded component, much like this, this USB port right here. And so if I want to test that hypothesis, I will touch one probe to there, and then I will kind of probe around. If I have another point that I also think is ground, I could touch to there, or I can just kind of go through here, and there I have found that I have a connection. And I can actually see on this board, because it is actually labeled, that that pin that I connected to, I can't get that in focus in the camera, but that's okay. So that actually is a ground pin there. And so that is usually going to be my first step whenever looking at an embedded system, is I want to find a reliable source of ground, and one that I can easily touch without it being really hard to keep a connection. So things like this USB port are awesome for that. And so that is very useful when I go into the second thing that I will commonly use a digital multimeter for, and that is voltage mode. So now I've switched over here into DC voltage mode. So this multimeter also does a bunch of stuff with AC voltage that I hardly ever use. I have used that only a few times in my entire career, and yeah, it's just not that common. So I'm going to touch my ground, my black probe here, to my known ground point here on the USB connector, and now I can probe around and I can actually start to see some voltages on the system. Let's see if I can find anything interesting. Those are like all not connected. There we go. So I found something that has, it's sitting at 3.3 volts. So what I will typically use this voltage mode for, primarily on embedded systems like this, is looking for what might be a digital signal that I can then use as a jumping off point, as a hypothesis, and then I would go test that hypothesis by connecting either a UART adapter, by just immediately guessing that it's UART, or a logic analyzer to take a closer look at that signal. So I have a program running here that is printing out data on the TX UART pin every 5 seconds or so. So I'm going to go ahead and probe that point, and you'll see about every 5 seconds that voltage just fluctuate just a little bit off of 3.3 volts. Just a little bit. There we saw it. We'll do it one more time. Oh, that was a really small fluctuation. Let's see it happen one more time. There, that was a really good one. Okay, so So that is the result of a digital signal being transmitted over, over this TX UART pin on this Raspberry Pi Pico. And we are seeing the drop in voltage, right? Now this digital multimeter is not sampling fast enough to actually interpret that digital signal, but it is averaging that voltage, and that's why you see just a little bit of a voltage drop from that 3.3 volt baseline voltage. So now I have a pin on this board, if I was reverse engineering it, if I didn't know already that that is, that I wrote a program that's transmitting data over that pin, that then I would be able to either directly connect a UART adapter to that if I want to just guess that it's a UART and then try to guess the baud rate, or I could use a logic analyzer to take a closer look at that potential digital signal. And that is what I use my trusty Fluke multimeter for in my everyday job. I'd like to thank you for watching this video about the tools that I use in my everyday job. So, thank you for watching. Please continue to like, comment, and subscribe. Tell me what multimeter you have. Tell me if it has some features that I should be looking into. I know there's a few that I don't use that often, but maybe I should start learning to use more diode mode on a multimeter. Let me know in the comments. Thank you, and have a great day.